afternoon. It is Sunday, late in the afternoon. This is going to be a long one. This is Woodbridge High School's Algebra 1 final exam. And it's a really good assessment, and it goes over almost all the things that I feel are important content that is included in Algebra 1. So I like this. This is a pretty good, is a really good assessment that is an excellent measure of whether you are ready to test out of Algebra 1. So starting off with inequalities, we have this formula, and it says y plus 5 is greater than or equal to 2. So with inequalities, we solve them just like equations. We're going to isolate the variable, and we get y is greater than or equal to 3 when you have greater than or equal to or less than or equal to. That means it's including, so we're going to have a closed circle. When you have less than or greater than, then you're going to have an open circle, which means that we don't include this in the boundary. So my solutions are going to be greater than or equal to -3. So I find -3 on the number line, and because it's equal to, I'm going to have a closed circle, and my solutions are greater than. So I'm going to go to the right. So which one of these is equal to my solution? That would be A. So the answer is going to be A. Again, we have x minus 8 is less than or equal to -4. We'll add 8 to both sides. We get x is less than or equal to 4. So this means that my solutions are less than or equal to 4. So I do my number line. I show where my border is between true and false, or solutions. I'm going to include my boundary, and then I need solutions that are less than. So that's going to be to the left. So which one of these goes to the left? Closed circle over 4. That goes greater than. That doesn't include the boundary, so I know, again, my answer is A. We're going to notice that there are a tremendous number of A solutions. Don't know why, but whoever made this assessment really liked the solution A. We have -1.4x is less than -11.2. We're going to divide both sides by -1.4. We need to remember that when we multiply or divide both sides of an inequality by a negative, that we must flip the inequality sign. Whenever we change the sign of a variable, we in a sense are moving it across the inequality. Since the variable is going to stay here, instead of physically moving the variable over to make it positive, because we go from a negative variable, negative coefficient, to a positive coefficient, we will physically flip the inequality. And then -11.2 divided by -1.4 is +8. So here's my number line. Here's my solution. X is going to be greater than, so I am not going to include my boundary, and I need values that are greater than. So I'm looking for an open circle at 8 going to the right. That is A. Lev earns $5.65 per hour working after school. He needs at least $245 for a stereo system. Write and solve an inequality that describes how many hours he must work to reach his goal. So if Lev gets paid $5.65 per hour, that would be his salary. That salary needs to be greater than or equal to $245. So we would divide by 5.65, divide by 5.65, and we get H must be greater than or equal to 43.36, blah, blah, blah. So we're assuming, I guess they're assuming, look at these, well, that's plus that value. No, that's multiplying. That's greater than or equal to, so that's good. And then we see that x needs to be greater than or equal to 44 hours. That would be B. And that's the same thing. This is a partial hour, so I don't think Lev can work a partial hour. So it makes sense that we would say that it's greater than or equal to 44 hours. Number 5, we have -7 times the quantity 4x minus 3 is less than or equal to -7. A high school student would get rid of this. We can't touch this because of Chewbacca. So we'll divide both sides by -7. Because we divided both sides by a negative, we need to remember to flip that inequality. So these cancel. You're left with 4x minus 3 is now greater than or equal to +1. We'll add 3 to both sides. 4x is greater than or equal to 4. Divide by 4, divide by 4. We get x is greater than or equal to 1. If we wanted to see that on a number line, close circle because it's equal to. My solutions are greater than 1, so it looks like that. And that is, I know, surprise, A. We're already seeing an abundance of letters of A. 13b minus 6 is less than or equal to 14b plus 8. I'm going to move the variables first. I always like moving the variables prior to the constants. That leaves me with b plus 8. I'll subtract 8 from both sides. -14 is less than or equal to b. And I would rewrite this since it's eating b. It still needs to eat b when I move it across. So b is greater than or equal to -14. And how funny is that? That is solution B. So we moved away from A's. Number 7, graph your solution. So we have 4x plus 4 is greater than or equal to 2 times the quantity x minus 2. I'm going to do a high school little thing here. I'm going to be smart and be efficient. I can simplify that. 2x plus 2 is greater than or equal to x minus 2. I'm going to move my variable. X plus 2 is greater than or equal to -2. I'm going to subtract 2 from both sides. That looks like a 3. That is really a 2. And we get x is greater than or equal to -4. Graphing it, 0, -4, including closed circle. My solutions are greater than, so it looks like that. Closed circle over -4 going to the right is A. We know it wouldn't be C or D, and we just want to make sure that my inequality, I didn't have a negative in here, so that is correct. Number 8, solve and graph. -4 is less than 2x plus 10, which is less than or equal to, sorry, I forgot the equal to 4. This is called a compound inequality. And something you need to remember, this is going to be an and, so compound, this is an and statement. So we're going to take -4 is less than or equal to 2x plus 10, and we're going to take this left side. So we break this into 2 statements. We have this statement, and then we have this statement. So the other part of that equation is -4 is less than or equal to 2x plus 10, and 2x plus 10 is less than or equal to 4. And now we solve it. -10 minus 10, -14 is less than or equal to 2x. Divide by 2. negative 7 is less than or equal to x, or x is greater than or equal to negative 7. All I did was flip it and wrote my variable first. And now I'm going to solve this one. 2x is less than or equal to negative 6. Divide by 2, divide by 2. X is less than or equal to negative 3. So x is less than or equal to negative 3. If we had to graph that, we have negative 7, negative 3. So this part looks like this. X is greater than or equal to negative 7. That looks like this. And then if we had to graph this, this is a closed circle at negative 3 and goes like this. And since it's an and, it needs to be what we call true, true. It needs to be true for this and true for this. So where in the graph, where in this graph do we find this inequality true for both of them? Well, let's look. This is true for green. Not for blue, because it's false for blue. This is true for green and blue. And then once we get here, this is just true for blue, but false for green. So where is the true, true is going to be, my solution is going to be negative 7, negative 3, 0. It's going to be a closed circle in between those two. And typically, and statements are segments. And so if we needed to write this as a compound inequality, you'd have negative 7 is less than or equal to x, which is less than or equal to negative 3. So this would be my written solution. This is how I would write that inequality. And let's look and see which one of my solutions looks like my answer. Hey, no way! I know, I can't believe it. A looks like my answer. Negative 7 is less than or equal to x, which is less than or equal to negative 3. We have a line segment solutions, closed circles for negative 7 and 3. It's a good, really good problem. The other problem that you might see in a compound inequality is an OR. And ORs tend to look like these. They have wings. I call these wings. This is a segment. These are wings. And notice the ORs have the wings, and the and statements have the segments. Not always, not 100% of the time, but 99% of the time. There are special situations. Your veterinarian tells you that a healthy weight for your dog is between 70 and 80 pounds. Write an inequality to represent your dog's healthy weight in W in kilograms. So these little stinkers give us pounds and then want it in kilograms. So the first thing we need to do is we need to convert 70 pounds is how many kilograms? Well, that's 31.751 kilograms, and 80 pounds is equivalent to 36.287 kilograms. So my dog needs to be between those two weights. So the weight needs to be greater than or equal to 70 pounds or less than or equal to 80 pounds. So if I substitute these values with the kilograms and they go out to the tenths place, we would have a statement that looks like that. And which one is that? That looks like it's C. So that would be C. And that's the weight in kilograms. I guess we could do kilograms here too for units. It's always important. It's a good question, but they were trying to be tricky. Solve the equation, the absolute value. So we know that absolute values measure distance, and there is no value that is going to come out of here. This will never, no matter what we plug in for x, nothing, negative numbers, positive numbers, whatever is going to pop out of here, because absolute value wants distance. Distance is always going to be positive. So This is always going to be a positive value, no matter what you plug in for x. So we know that a positive value will never equal a negative value, so my answer is no solution. Good concept. You should know absolute values, and here's more absolute values. So this says the absolute value of 4x plus 2 equals 3. So it says what distance, what number has a distance of 3? So this could either, this whole value could either equal negative 3 would kick out a 3, or positive 3 would kick out a 3. So this needs to simplify to either 3. So this needs to either equal 3, or that value needs to equal negative 3. You understand that? So if this simplifies to 3, so we kind of don't see it anymore. So this, if this equals 3, if this is 3 inside the box, the absolute value of 3 is 3. And if this equals negative 3, meaning if there's a negative 3 here, that still produces that. So that's why we do that. That's a understanding absolute values and why we write two statements. So we'll subtract 2, and now we solve. 4x equals 1, divide by 4, divide by 4, x equals 1/4, minus 2, 4x equals negative 5, divide by 4, divide by 4, x equals negative 5/4. Those are my two solutions, and I will always write it in a solution set in numerical order. And unfortunately, this book is not, or these solutions are not very nice. They are not in numerical order, even though it is A. So if we could check by plugging in 4 times negative 5/4 gives us negative 5 plus 2 is negative 3. The absolute value of negative 3 would produce positive 3. So you could check also. Now we have an inequality. This is compound. The absolute value of x plus 3 is greater than or equal to 3. When we have absolute values in inequalities, if you have greater than, it's or. If you have less than, it's and statement. So this is an or statement. So we get x plus 3 is greater than or equal to 3, or x plus 3 is less than or equal to negative 3. We still need that positive or negative distance, right? This can be positive or negative, and we need it to be, but because we changed the sign, we have to also change the inequality. And now we solve it. So x is greater than or equal to 0. Minus 3, x is less than or equal to negative 6. And this is an or. Since it's an or, we're probably looking for the wings. So let's look at this. We'll write this statement. X is greater than or equal to 0. This is my 0. This is my negative 6. So this is going to be a closed circle going this way. We'll write this one. X is less than or equal to closed circle going that way. So since it's an or, we only need one true, at least one true. And so this is 1, this is none, this is 1. So my solution is going to be this inequality, or this graph will look like this, and it'll be an or statement. So negative 6 going to left, 0, x is less than or equal to negative 6, or x is greater than or equal to 0. So that would be A. I know, oh my goodness. That's so weird that it came out as A. Yep. That's like 8 or 9 of the 13 answers of the first 12 have been A. Solved. So here this is greater than, so we still have an or statement. So I'm going to write x plus 6 is greater than or equal to 1, or x plus 6 is less than or equal to negative 1. And now we solve each of those inequalities. Or minus 6, x is less than or equal to negative 7. If we graph those, negative 7, negative 5, 0. Let's graph this. X is greater than or equal to negative 5. That's a closed circle going that way. Let's solve this one. Closed circle looks like that. So which one is that? Negative 7, closed circle going that way. Negative 5, closed circle going that way is going to be A. We know it's not this because they're equal to. We know it's not this because that's an and this is not including, and that's an and statement also. All right, here's our first graph. So let's look at this graph. Let's do this. So how we graph inequalities. First of all, I'm going to take this statement, negative y is greater than or equal to x minus 1. I'm going to isolate for y. I'm going to get y by itself because I want it in slope-intercept form. So I'll multiply both sides by negative 1. We need to recognize that we multiply by a negative. If we multiply by a negative, then we have to flip our inequality. So the statement now becomes y is less than or equal to negative x plus 1. We're going to distribute that negative 1 to both of those terms. This tells me that I have a slope of negative 1 and a y-intercept of 1. And that's just my border. So I'm going to have a closed circle. We need to remember that when we have not only when we have greater than or equal to do we have closed circle, but we have a solid line. And when we have a less than or greater than, we have open circle on our points and dotted for our border. So this represents our border between true and false values. So my slope, my y-intercept is 1. I'm going to do a closed circle at 1 because I'm including it, and I'm going to have a slope of 1. Slope of 1 is down 1, right 1, down 1, right 1. And then we're going to have a solid line because it's equal to. And so those are all true solutions. Those are true. Those are solutions to this inequality. And now I have to figure out one side's going to be true, one side's going to be false. So I don't know which side is true yet. I know this line is true. Any point on that line would give me a solution. So I need to figure out which side. If this point is true, then all of the points are true on this side. If this point is false, all of them are false, and this side is true. And I always shade the true. So we test a point. What's the easiest point on the coordinate plane to test? That would be 0, 0. So we're going to test it and put it into this inequality. So we plug in 0 for y, and we plug in 0 for x. That's all we're doing is taking those values and plugging it in and then simplifying and seeing, is this a true statement? Is 0 less than or equal to 0? Is 0 less than or equal to 1? Yes, that's a true statement. So this testing point is true. So we know that this point here is true. That means everything on this side is true. If this point on this side is true, every point on this side is true, and every point on this side is false. So which one has a shaded, what looks like that? I know. How crazy is that? A. So this looks very similar to it, and that's my solution. This one, again, we are going to have a graph. We're going to graph this. I'm going to graph it on my own graph first, and then I'm going to compare it. So the equation is x is less than or equal to negative 7. Well, This is a peculiar one because there's only one variable. When there's one variable, I know it's either horizontal or vertical. If it had two variables, then it would have slope. But since this only has one, it's going to go through this axis at this point. So it's going to go through the x-axis at -7, and it's going to be a closed circle, and it's going to be a line that looks like this, because we notice that every point on here, x equals -7, and now we have to test. This border is going to be true, hence why I did solid line and closed circles. And now I have to test to see which way I'm going to shade. So I again am going to test 0, 0. So I'm going to put 0 in for x. Is 0 less than -7? That is false. So this point 0, 0 is false. All the points on this side are going to be false. So all the points on the other side must be true. This side is false. The other side will always be true. So which one of these looks like my graph? Yes, A looks like my graph. Yep, I know. So that is the correct answer. Number 16 of 54, I think. We have 54 problems. Solve the system by graphing. These are equations, so this represents x plus y equals 0. Let's get our graph again. X plus y equals 0 is a line. It's a linear equation. So this represents a line. It's an I'm going to do this down here. Let's bring this down because we're going to need a little space. So this is a linear equation. It is in standard form. Typically when it's in standard form, I'm going to find the x and y intercepts. But because these have the same x and y intercepts of 0, x-intercept is 0, y-intercept is 0, I'm going to actually subtract x, and I'm going to put it in slope-intercept form. Y equals -x tells me I have a slope of -1 and a y-intercept of 0. So I'm going to take that equation and I'm going to do this in green. So this will be my green line. So green looks like this. It is a y-intercept of 0 and a slope of -1, down 1, right 1, down 1, right 1. And I have my graph looks like that. And why does it have a slope of down 1, right 1? Well, -1 is in slope as a fraction is -1 over, and we have rise over run. So rising -1 is down 1, and running +1 is right 1. So that's why my slope is down 1, right 1. My other equation, let's take a peek at my other equation. We'll do this in blue. And that is y equals 4x plus 45. This has a slope of 4 and a y-intercept of 45. How am I going to graph that? So my y-intercept is going to be way the heck up here somewhere. And my slope, or my y-intercept is going to be here. My slope is down 1, right, sorry, my slope is 4 over 1. That's up 4, right 1, up 4, right 1, up 4, right 1. So it's going to be moving, right? Has a slope of +4. Yeah. So my y-intercept is going to be way the heck up here, and I'm going to go up 1, right 1. So it's going to have, my slope is going to have that angle. That is a positive angle from that point. So I know that if I have a positive slope, it's going to look somewhat like this off of 45. So Which one does that look like? It could be A, could be C, can't be B because my green line doesn't have that. Could be D. Now, this is never going to hit. This has a negative intercept. This could be, but this has a negative slope. And this could be positive 45, and it has a positive slope. So I'm going to say A. And that's a hard one because these numbers, this line is crazy up there. But notice it would intersect somewhere, something similar to it. So that's not a great example. It's not a good problem to provide for students. Just you're really not going to be able to graph it. All right, these are two systems. They want you to solve through substitution. You have three ways. You have substitution. You have addition and subtraction. You have multiplication and then addition and subtraction. You also technically have graphing. You can graph systems to find the solution. And it really is, these are two lines. They want to find out where they intersect. The intersection would represent the solution. It's systems want to know what value do both of these equations share. So through substitution, we're going to, since this bottom equation is solved for y, we're going to take this and plug it in for y. That's what substitution is. So we'll take this equation, 3x plus 2y equals negative 4, and where we see y, we are going to substitute 4x minus 2 equals negative 4. And what this provides us is, now we only have one variable. So we will distribute this in. We get 8x minus 4 equals negative 4. 11x minus 4 equals negative 4. Add 4, add 4. 11x equals 0. Divide by 11. X equals 0. That's my x value of the solution. And then we can use either equation, but this is nice because I have my x value. I'd like to find my y coordinate, and this is set up nicely. We're going to substitute 0 in for x so we can find out what my y value is when x is 0, and my y value is negative 2. So I know that the solution is 0, negative 2. Which one is 0, negative 2? To no surprise, A. Number 18. Number 18, the length of a rectangle is 8 centimeters more than 4 times the width. If the perimeter of the rectangle is 46 centimeters, what are the dimensions? So we have this rectangle that is length by width. And it says the length is 8 centimeters more than 4 times the width. So I don't know what the width is, but I know the length equals 4 times the width plus 8. So now we use the equation perimeter equals 2L plus 2W, and we start substituting values. So I know that my perimeter is 46. I know that my width is W, and I know my length is going to equal 4W plus 8. So perimeter is 46 equals 2 times the length, which is 4W plus 8 plus 2W, and let's simplify. 46 equals 8W plus 16 plus 2W. Simplify both sides first. 10W plus 16. Let's minus 16. 30 equals 10W. Divide by 10. Divide by 10. 3 equals W. So my width is going to be 3 centimeters. And then if this is my width, or this is my length, 4 times 3 plus 8 equals 12 plus 8, which gives me 20 centimeters for my length. So what has a width of 3 centimeters and a length of 20 centimeters? That would be A. I mean, it's not even surprising anymore. Number 19, solve through elimination. So here is a great example of elimination through addition and subtraction. I called it addition, subtraction, or multiplication. It's called addition because we're going to add these two equations. It only works when they're in the same format. This is called standard form. This is ax plus by equals c, and both of those equations. And now we're going to add the columns. So we're going to add up the like terms. We're going to add up the like terms. We're going to add up the like terms, the like columns. They have to be on the same side. And so 3x and x gives me 4x. Notice positive 6y, negative 6y, eliminate, equals 20, divide by 4, divide by 4. I know my x value is 5 in my point, in my coordinate, and then I can use either of the equations. I'll use 3x plus 6y equals 9. I'm going to substitute 5 for x to find out what my y value is. This is 15 plus 6y equals 9, minus 15, minus 15. 6y equals negative 6. Divide by 6, divide by 6. Y equals negative 1. So my coordinate is 5, negative 1. The x goes in the x coordinate. The negative 1 goes in the y coordinate. And that would be A. Solve the system, so I can choose any method: substitution, elimination, graphing. Well, it's set up because these y's are going to cancel, so it naturally lends itself to using the elimination method. So we will add these columns. This gives me 7x. My y's cancel, and this gives me negative 35. Divide by 7, divide by 7. X equals negative 5. And I can pick either equation. I'll pick the bottom one this time. 3x minus 4y equals negative 23. I put in my x value, and I will solve for y. Negative 15 minus 4y equals negative 23. Let's add 15 to both sides. Negative 4y equals negative 8. Sorry, I'm repositioning myself. I got a little lazy. I was literally almost lying down here in my chair. Y equals 2. So my x value is negative 5. My y value is negative 2, which, oh my goodness, it's D. It's not A. They changed it up on us, those little tricksters. All right, number 21. We again are going to solve the system. I could do elimination, but I would have to multiply by negative 1 for one of these, or I could use subtraction technique. I'm going to use the substitution method. I'm going to take this equation, 3x plus y equals 0. I'm going to subtract 3x. And that gives me, that gives me y equals negative 3x. And now I'm going to substitute. So I'm going to substitute this value in for y in the other equation. So 3x plus 4y equals negative 9. You must substitute it into the other equation. So 3x plus 4, instead of writing y, we're going to write negative 3x equals negative 9. 3x minus 12x equals negative 9. Negative 9x equals negative 9. Divide by negative 9 gives me x equals 1. And the nice thing about that is we can take that equation and use it to find my y value. So y is going to equal -3. So I get a point, a common point between those two equations would be 1, -3. Uh-oh, that is back-to-back problems where it wasn't A. Okay, we'll see how long that lasts. Mark, thought that said M-A-R-E. Mark sold 461 tickets for the school play. Student tickets cost $3. Adult tickets cost $4. Mark's sales totaled 1,624. How many adult tickets and how many student tickets did Mark sell? So we're going to write two statements. When we deal with systems, we write two equations. Since we sold 461 tickets, this is going to be one of the statements, and we know that there are student tickets and adult tickets. So from that, I can write this. Student plus adult is going to equal 461, where S equals the number of student tickets, and A equals the number of adult tickets. So that's that first statement, and then I'm going to write an equation using this information, also this and this, as well as the total, because this is the number of tickets, this is the total value. So if each student ticket is $3, if I take 3 and multiply it by the number of students, I get the amount of money drawn from student tickets. And then adult tickets is $4, so I could write 4 times the number of adults would give me the total money, and then I raise $1,624. So those two statements, I can do a couple of things. I can either use elimination or I can do substitution. Both work. I'm going to do elimination. I'm going to multiply this top equation by -3. And if I multiply everything by -3, even that value, I get -3s minus 3a equals -1,383. And then I just bring this equation over, which is 3s plus 4a equals 1624. And now I'm going to combine. I'm going to add them. These cancel. This leaves me with A, and this leaves me with 241. So I know that I have 241 adult tickets. So that's something that's good. And then I can use this equation. I'll bring that down. Let's do it in another. S plus A equals 461. And if I know that I have 241 adult tickets, I can substitute that in and then subtract. And that tells me that I have 220 student tickets. So 220 student tickets. So which one? 220 adult? No, 241 adult. Oh, look at that. That's D. 241 adult, 220 student. Whoa, A is long gone. We will probably never see another A. It'll probably be B, C, or D for the remainder of this assessment. So it says describe the solutions of the system. So we have this 6x plus 4y equals 10, 8x plus 12y equals -20. So I'm going to use elimination, but I'm going to multiply, meaning I'm going to cancel one of these variables. I have equals -20. So I'm going to cancel. So I need these x's to cancel. I'm going to have to, If I'm going to cancel these x's, these coefficients have to be opposite of each other. So how can I make this value equal to the opposite of 18 or negative 18? How can I make this? What can I multiply 6x to make it negative 18? Well, I would multiply it by negative 3. So I'm going to multiply everything to keep it as an equivalent equation. So that new equation, that is equivalent, it's not new meaning it's different, that's negative 18x minus 12y equals negative 30. And then I just bring this over, 18x plus 12y equals negative 20. And now I'm going to add them. These cancel. These cancel also. So I'm left with 0 equals negative 50. And what do we know about it? The variables canceled, and it gave me a false statement. So there is no solution. There is no place where these two lines, these are lines, these linear equations will intersect. So tell me, what do you think? How could those lines be drawn if they don't intersect anywhere? So if we have this, we have these lines, how could that look? They'd have to be parallel to each other. That's the only way they would never intersect. So we know that these two lines are parallel lines. Parallel lines have the same slope, but different y-intercepts. If they had the same slope and the same y-intercept, they would be the same line. They would be the same line, and the same lines, what type of solutions would that? That would have an infinite number of solutions. That would be all points on the line. So there would be an infinite number of intersecting points. That's completely different. That's if when our variables cancel and we create a true statement. This would be a true statement. This is going to be our false statement. No points intersect. All points intersect. So in this case, it was false, so that's why it's A. Good. You should know both cases. All right, now we have systems of inequalities. And I'm going to pull out a new graph because I want to draw it. So how are we going to do this? We're going to do both equations. Well, let's do this. Let's use our highlighter. So let's do this one. This has a y-intercept. This is a closed circle because it's equal to. So negative 1 with a slope of 2 up to right 1, up to right 1. That looks like this. Now we would test. Let's test the point because here's my border. I'm going to include all the points on the border. They're true, but I need to see which side is true. So I'm going to test that 0, 0. So if I test 0, 0, okay, 0 less than or equal to 2 times 0 minus 1 is 0 less than or equal to negative 1. No, that's false. So this point is false. So that means I'm going to shade this side of the border. And now let's do this one. Let's graph this. This is going to be, since there's only one variable, we know it's going to be either vertical or horizontal. This is going to go through the y-axis at negative 3. This is my y-axis at negative 3. 1, 2, 3. It is open circle because it's not equal to, and that means negative 3 is going to go, it's going to be a dotted line because all of these y values are negative 3. And we're going to test. We still will test 0, 0. We'll do the testing 0, 0. So my y value is 0. Is 0 less than negative 3? That's false also. 0 is not less than negative 3. So this would be false. So this would be true. All the true values would be in this location. So where do we get true, true? This is false, false, false for green, false for blue. This is true for green, but false for blue. This is false for green, but true for blue. And this is going to be true for blue and true for green. So my shaded region is going to be here with a dotted line for the blue equation, solid line for the green equation. Which one of those looks like my solution? B. Yeah, that's B. Dotted line for the horizontal, shaded in this area, solid line. So that would be B. Number 25, this time we have 3 equations that we have to graph. All right, that's not the worst thing. So let's take the first equation, 5. Oh, well, actually, let's get our graph, and let's bring you down a little bit, because we're going to take these equations and we're going to graph them. So let's go. Green is going to be 5x plus 3y is greater than or equal to 15. So remember how I said that this is in standard form where you can find the x and y intercepts? Well, when we find the x-intercept, my y value is 0. So that's going to go away. So I'm left with 5x and 15. What value, if we solve for x, that gives me 3. So my x-intercept is going to be 3. And if I'm looking for the y-intercept, my x value is 0. So that eliminates this term. And I would divide by 3. My y-intercept is going to equal 5. So this inequality is going to have an x-intercept of 3 and a y-intercept of 5. And we're going to make dots close circles because it's equal to. So x-axis is going to be 3. Y-axis is going to be 5, 2, 3, 4, 5. And we connect the dots. Now we have to test it. Let's test 0, 0. So 5 times 0 plus 3 times 0 is greater than or equal to 15. Is 0 greater than or equal to 15? That's false. So this point 0, 0 is false. So I know that I have to shade up. Let's do the next equation. This says x is greater than or equal to y. I'm going to rewrite it with y first, and that would be y is less than or equal to x. This has a slope of 1 and a y-intercept of 0. And we're going to include my y-intercept of 0, and we're going to have a slope of 1. So that looks like this. And that is a closed circle because it's equal to. Now I can't test 0, 0 because that point is on the border. I know it's going to be true. So I have to pick another point. So I'll pick a point somewhere that's probably to the right of this also. So I don't know. Let's try 5, 0. I like that. So if we test 5 for x, 0 for y, so we put in 0 and 5. Is 0 less than 5? That's true. So I know that I'm going to shade in this direction. And the last equation is x is less than or equal to 6. So we know that there's only one variable. So it's going to be horizontal or vertical. So that's going to be a closed circle at x. Where is x? 6. 1, 2, 3, 4, 5, 6. And it's a closed circle. So it's going to look like this. And if we test 0, 0, 0 less than 6, that's true. So I'm going to shade to the right. Now I have to decipher all of this noise. Where is it true, true, true? Well, it's false for green, false for blue, but true for black. It is true for green, true for black, but false for blue. And so, yes, it's going to be this little shaded region here. Which one is that? Oh, we're back to A's. So that would be, my answer would be A. That's fun. I like those. I like it because it takes a lot of attention to detail, and I like detail. All right, now we are moving on to exponents. When we multiply like bases, what do we do with their exponents? We are going to add their exponents. So 4 plus 5 plus 6 gives me 15. R to the 15th is C. And we've moved away from A's again. Good. Let's see what we got. We got a, oh, go. Very fun. I just got a, I like that. Mr. Floyd sent me a picture of a pencil over a bookstore or some type of pencil store. He knows that I'm a teacher and that I would enjoy this. All right, we're going to multiply these. So this really says W times C to the 7th times -8 times W to the 3rd times C to the 5th. And we're going to combine like bases. When we multiply like bases, we add their exponents. So we have W to the 1 plus 3. And we have like bases here. So we're going to combine we're going to add their exponents. And then this is a coefficient, and that coefficient's just going to sit out front. So my answer is going to be -8 W to the 4th, C to the 12th. Now, Mr. Mack would rewrite it. I would always put it in standard form, that is alphabetical order, but we notice here they don't. Bad. I don't agree with that. I think that it should be -8 C to the 12th W to the 4th instead of A here, which is written in that way. You're going to find in high school math books and college math books that they always put it in standard form where it's alphabetical order. So that's a contradiction. Here we have variables. We have exponents inside and then an exponent. So this is a power of a power. Technically, we have x to the 3rd times y to the 8th times x to the 3rd times y to the 8th times x to the 3rd divided by y to the 8th times x to the 3rd y to the 8th. We have 4 of these. That's why that's the power. But this, what if we had 10 or -10? What would you do? How many would you do? Nah, that's just too much work. Way too much work. When we have a power of a power, we can distribute into exponents when they're being multiplied. We cannot distribute exponents when being added and subtracted in here. So when you take a power of a power, you're going to multiply. And we distribute that multiplication into each of those. So that's x to the 12th, y to the 32nd. That's going to be A. The rules of exponents are very important. Very, very important. Here, we're dividing like bases. When you divide like bases, you subtract their exponents. And that takes place in the numerator. So this is 3 to the 3rd, which is C. Now, this is interesting. They did not write the correct answer in the answer key. I don't know what it is, but let me help you. This is correct because we have 3 to the 8th is 4, 5, 6, 7, 8, and 3 to the 5th is 2, 3, 4, 5. And guess what? This cancels, this cancels, this cancels, this cancels, this cancels, and you're left with, yes, 3 to the 3rd. So that's why it's C, and that's why you subtract them. So the answer key is wrong on that. So keep in mind, this is 2 to the 2nd plus 9 plus 7 to the 0. We're going to do exponents first. 2 to the 2nd is 4. 7 to the 0 is 1. And then we have 14. This one is incorrect also. They didn't like writing C. They probably wanted to write A. But this answer is also incorrect in the answer key. 7 to the 0, let's look at this. If you have 7 to the third over 7 to the third, we know that anything over itself is going to equal 1. And then if we use the division of exponents, that's 7 to the 3 minus 3, because we're dividing, we subtract. And that's 7 to the 0. So that's why anything to the 0 is equal to 1. It was a bad 0. And that's the reason why 7 to the 0 is equal to 1. You have identical exponents in the numerator and denominator, which is a value of 1. 31, we're going to write using positive exponents. Well, we have 5 to the 0 times 5 to the negative 12. Since we have like bases, we are going to add their exponents, and that would be 5 to the negative 12. And then you can't have negative exponents, so when we change the sign of the exponent from negative to positive, we change the location of the base. It's currently in the numerator, so in order to make it positive, we put it in the denominator. When you change the location, when you change the sign of the exponent, you change the location of the base. So that is going to be B. Good. All right, now we have scientific notation. 2,239 has a decimal point here. Scientific notation needs to be greater than 1 and less than 10, or greater than or equal to 1 or less than 10. So I'm going to move this decimal point until that value is between 1 and 10. It's 213 right now, or 223. It's 22.39, and now it's 2.239. So if I move that decimal point to here, and then each place value is a 10, so that's 1, 2, 3, so that's 10 to the third. So my answer is going to be A. 2.239 times 10 to the third is its equivalency in scientific notation. When we multiply scientific notation, we are going to multiply their base numbers. They're not base numbers, they're kind of like coefficients, and then we're going to multiply their base 10 numbers. Those will also multiply. And so 3.5 times 8.2 times, and since we have like bases and we're multiplying, that's going to be addition. So that's how it looks. 3.5 times 8.2 gives us 28.7 times 10 to the negative 6. Now, I would not leave it like that. I would not do it. That is one of the answers. To me, your answer should still be in scientific notation, so I would move it one place, and I would write 2.87 times 10 to the negative 6 plus 1, because I have that one place value, and I'd write 2.87 times 10 to the negative 5 is the answer I would have provided. But whatever, they have a different answer key than I do, or expectations. I'm just a lowly algebra, 8th grade algebra 1. All right, the calorie and the BTU, the British thermal unit, are two standard units of energy. 2 calories is about 0.007936 BTU. How is this measure expressed in scientific notation? So we would take this value, 7936, and now we're going to move this decimal point 1. It's not between 1 and 10. It's still not between 1 and 10. Now it's 7.9, so that is between 1 and 10. So we would write 7.936 times 10. Now we made a smaller, we're going into the smaller digits. So this is going to be negative, or it's going to be divided by 10, or 1/10, multiplying by 1/10, which is -1, -2, -3. So that's how we would express that. That would be B. Whenever we move to the right, that's making a smaller number. There's lots of different ways to remember moving of the decimal point. I love this problem. This is compounding interest. So we have A equals P times the quantity 1 plus R times N, where A represents the balance, your final value. P is your principal, your starting principal, your starting money. R is equal to rate, and it needs to be in a decimal, and N is the number of years. So we're looking for A, my principal. What is my principal? So let's do this. My principal, how much money do I start with? Invest. So I invest $150. My rate is going to be 10%. I'm going to have to convert that to a decimal. And then what is my N? What is the number of years? 5. So I just plug in those values. P is 150, 1 plus the rate. So 10% as a decimal is 0.1, and N is going to be 5. So A equals 150 times 1.1 to the 5th. Now I need to recognize I can't multiply before I do my exponent, so I will have to do the exponent before. So I have to do 1.1 to the 5th power. So using our calculator, 1.1 to the 5th power equals that value, and now I'd multiply it by the 150 times 150 gives me $241.58. So I'm going to have to round to the nearest penny. So A equals, we got $241.58 because it was 241.576. We round there. So that becomes 8. And for some reason, the book says 242. I don't know why you would round to the nearest dollar. That's not A. I'm so used to saying A. I don't know why they would round to the nearest dollar. It doesn't say that you can only pay in dollars. Most banks aren't going to round up to the nearest dollar. I assure you, banks are made to make money, not to protect your money. I assure you. So just be careful of that one. That's an interesting discrepancy again, where they have a different solution than we do. Number 36. 36, if there is initially 35,000 bacteria in a culture, and the number of bacteria double each hour, the number of bacteria after T hours can be found using the formula N equals 3,500 times 2 to the T. Now, this is an exponential growth problem because my variable is an exponent. So how long will it take the culture to grow to 35,000 bacteria? So it wants to know, when is N 35,000? So we're going to substitute 35,000 in for N, and we have this problem. Let's get rid of the 3,500. We're trying to isolate T. So we're going to divide both sides by 3,500. These cancel, 350 divided by 35 gives me 10 equals 2 to the T. Now, 2 to the T. So how do we solve for a variable when it's an exponent? Well, let's remember, go back to logs. Remember, 2 to the 3rd equals 8, and I can write that in log. Log would be log 2 of 8 equals 3. Remember how I showed you in star testing that you start here, you go around clockwise. That was a horrible drawing. You go around oh, no, we go around clockwise to this, and then it equals this. So 2 to the third equals 8. So this says log 2 equals 8. And notice, we've got this looks like, yeah, we can write it, 2 to the t equals 10. So let's substitute those things. How could I write this as a log? That would be log 2 of 10 equals t. Hey, now I have my variable in a nice place. So how do I deal with log 210? Well, on our calculator, we don't have log 210. So we actually do this. Log of 10 divided by log base 10 of 2 will equal t. And that is a nice way of converting from log 2 to log base 10. And log base 10 is in here. We see this. So we say 10 log 10 divided by 2 log 10, and that equals 3.3219, blah, blah, blah. So that's 3.32. So 3.32 equals time. Time is in years, so it's approximately 3.32 or hours, excuse me, number of hours. So it's going to be D. Yeah. Now that is a super advanced Algebra 1 problem. More probably Algebra 2. Not many schools are going to get into, and not many elementary schools are going to get into logs, but this is a nice way to deal with logs when it's not base 10. We convert it to base 10 by putting this in the numerator, this in the denominator. It's kind of cool. It's a neat little trick when you have a calculator. Some calculators, scientific notation, those fancy ones, you can do logs, any log base. This is log base 2 that I converted to log base 10. So just a little info there. Problem number 37. Are we at least an hour in? Again, we see that these are exponential growth or exponential decay. And when my coefficient or my base of my variable, this says what that says is y equals 1/2 to the x. And when this base is less than 1, it's going to be a decay. And this looks like a decay. But there's a number of other ways. Let's say you didn't know. Well, let's do a graph or a chart. Let's do an H chart. Let's plug in some values and see what we get. So if I plug in 0, y to the 1/2 to the 0, well, that's equal to 1. What if I plug in 1 for x? Y equals 1/2 to the 1. Well, that's equal to 1/2. What if I do -1? What is y to the 1/2 to the -1? Well, remember, negative takes reciprocal, so that just equals 2. So I have a couple points here, 0, 1, 1 comma 1/2, -1, 2. So if I can find enough points to sort of get the shape of my equation of this graph, that's pretty good. So I'm going to do a couple more. I'm going to do 2 because I can get a couple more in there. 2. What is y to the 1/2 to the second? Well, that's 1/2 times 1/2, which is 1/4. And since I have the negative exponent, I'm going to know what 1/2 to the -2 is just going to be the reciprocal of it, so 4. So let's take a graph. Let's see what that's going to look like. What is that graph going to look like if I plot these points? So if I graph these points, so my first point is 0 for x, 1 for y. 0 for x, 1 for y, looks like that. Then I have 1/2, so 1 on the x, 1/2, looks like that. Then I have -1, 2, and then I have 2, 1/4, and I have -2, 4, which is that. So I kind of see the graph looks like that. Yeah, that's the shape of my graph. So now can I decipher? Well, I know it's not A. I know it's not C. Oh, it's B. Super easy. That looks like my shape. So that's how you find, that's a nice way of doing that problem. By plotting a couple points, plugging in a couple X values, finding out what the Y values are, and graphing it. Number 38, write an exponential function to model the situation. Population of 470 animals. That's your starting value, decreases at an annual rate of 120. So we have AX to the N is kind of how we do it. Or to the X, sorry. Let's do, maybe it's N to the X. That's what it is. A to the N to the N to the X. So, oh, maybe even R, because that's my rate. It's kind of like my rate. So A is my starting value, 470, and it's my, that's not a good 70. And then it's my rate. Now my rate, a lot of people would do 12%, but it's decreasing. So what is my rate? It's not 12, it's going to be, this formula really is 1 minus the rate. So this would be 0.88 to the X, because 88% is the increase, it's decreasing. So this is how you would write it. And we would get D. And because it's decrease, it's a decaying, we would have a value less than 1. If it was an increase, it would be a 1.12. Increasing at 12% would be 1.12 would be inside there if it was a exponential growth. So good question. Again, probably not going to see it in too many high school Algebra 1 curriculums. You will see it in a high school Algebra 1, and you will definitely see it in Algebra 2. So number 39, we got about 15 problems, 16 problems left. Find the degree of the polynomial. So you have to make sure it's in standard form, descending order, highest exponent, and you look at the exponent, and it's to the fourth. So it is A. That's your fourth degree polynomial. It's actually a fourth degree trinomial. Don't let the coefficient has nothing to do with it. It's just the exponent. That you will see in 8th grade. Simplify the expression. We're going to see this year. So we have 5q to the 5th, to the 5th plus 4 minus this quantity 2q to the 3rd plus 9. And then we're going to add this quantity to the 5th minus q to the 3rd. So this just comes right out. This we have to distribute the negative into both of those values because we want to do the opposite of it. So minus 2q to the 3rd minus 9. This positive is not going to change anything inside, so we can just pop that out. And now we just want to, we can do two things. We can write this in descending order via the power. So plus 6q to the 5th minus 2q to the 3rd minus q to the 3rd plus 4 minus 9. That's kind of easier to see, the like terms. These are like terms, same variable, same exponent. We're going to combine their coefficients. So that's 11q to the 5th. I'm really getting lazy with my writing because we're on problem number 40. We're going to combine these like terms. These are like terms because they have the same base to the same exponent. So we're going to combine their coefficients. -1 and -2 makes -3q to the 3rd. And these are like terms, which makes -5. Notice they did put this answer in standard form. So q to the 5th minus 3q minus 5. We're back to always A answers. Number 41. Stick with me. We're almost done. This is multiplying binomials. Binomials, two terms, a binomial times a binomial. We are going to use what some people call FOIL. FOIL, first, outer, inner, last. First, outer, inner, last. I call it double distribution. We're going to take this first term and we're going to distribute it to both of these terms in the other binomial, and then we're going to take this term and distribute it to both. This is firsts, the first of the binomials, outsides, the outer two, inside, and last. So FOIL is still the same thing. So we have 4x times 4x. Then we have plus 4x times negative 3. Now we're going to distribute the positive 1 to the 4x and the positive 1 to the negative 3. 4x times 4x is 16x squared. 4x times negative 3 is negative 12x. 1 times 4x is 4x. 1 times negative 3 is negative 3. We are not done. We have like terms as our middle two terms. 16x squared doesn't have a like term. That's going to give me negative 8x minus 3. Notice they have it in standard form, and that is going to be b. It's not b. That's not a positive 3. This is a negative 3. It's going to be c. 16x squared minus 8x minus 3 is c. You should know, we're going to learn that. That is something you must be proficient at. Now, we have double distribution again. We can still distribute. We're just going to distribute 3 times. It's a binomial times a trinomial. And we'll take this term and we'll distribute it to all 3 terms of the trinomial. So we have x times x squared plus x times negative 2x plus x times 3. And then we're going to distribute the 5 times x squared plus 5 times negative 2x plus 5 times 3. That's x cubed minus 2x squared plus 3x plus 5x squared minus 10x plus 15. So this doesn't have any like terms, so that's going to be my highest. This has a like term right here, so we'll add those two coefficients. Negative 2 and positive 5 makes positive 3x squared. And these have like terms, so we'll combine their coefficients. So positive 3 and negative 10 is negative 7x. And then this doesn't have any like terms, so plus 15. And that's in standard form, descending. Nothing else can be added. X cubed plus 3x minus 7x plus 15 is A. We are going to multiply. These are called conjugates. This is one of those conjugates. Conjugates have the same terms, but they're opposites signs inside the binomials. And what happens here is some things cancel. So if we do our double distribution, 5c times negative 6 and positive 6 times 5c and positive 6 times negative 6, we get 25c squared minus 30c plus 30c minus 36. So you notice that my outside and my inside, when I multiply conjugates, these are my firsts. This is my first, and these are my last. That's why we call it FOIL. My outside and insides are going to cancel. They're always going to be opposite of each other. And so I'm just left with my first and last. So it's 25c squared minus 36. And we call this the difference of squares. Conjugates produce the difference of squares. So we're going to have to go in the other direction at some point here. It's called factoring. This is multiplying and this is factoring. So conjugates are really fun. They're easy. You just multiply the first and the last, and you'll get your answer. So that is through lots of repetition, lots of practice. All right, here's factoring. We have to break this into two binomials. Mr. Mack teaches his students this technique called A times C. There's a number of things. Is it in standard form? 2 is there a common factor amongst the three terms? Is it a special case, meaning is it a binomial square or the difference of squares? There are four characteristics for binomial square, 3 characteristics about difference of squares, and if it's neither of those, then we do A times C. My A value, this equation is written ax squared plus bx plus c. That's an expression, excuse me. And my A and C value. So my A value is 1. My C value is 5. So 1 times 5 is 5. And then I want to find factors of 5, which are 1 and 5. The signs are the same because multiplying two binomials, well, we'll get into that later, and they're both positive. So we do this little technique that equals my middle. So these are going to be my outside and inside. So I do x squared plus x plus 5x plus 5. All I did was this is going to equal this, x plus 5x. So I haven't changed the equation. I've just turned this from 3 terms to 4 terms. FOIL, this is first, outer, inner, last. And now I'm going to factor by grouping. I'm going to group the first 2 and the last 2. I'm going to look at the first 2. They have a common factor of x. If I factor out the x, I get x plus 1. I'm going to look at the second 2. They have a common factor of 5. And I factor out the 5, I get x plus 1. Notice we have like quantities, so I will pull that out, x plus 1, and that leaves me with x plus 5. So I just factored that expression. X plus 1, x plus 5, that's going to be C. So that is that. You should go onto my website or to my YouTube channel and watch how to do that, and you should practice that hundreds of thousands of times, because in this one you probably could have eyeballed it. When you get so good you can eyeball it. All right, now we turn that into an equation. We get 16g squared plus 40g plus 25 equals 0. We're going to use the zero property of multiplication, meaning anything, how do you get 0 when something's multiplying? Well, the only way you can get 0 is if one of these unknowns, one of these boxes is equal to 0. Opposites don't change, right? 5 times negative 5 don't cancel to make 0. The only way you can get a 0 through a product is one of these unknowns has to be 0. So we want to turn it into the product of two things. Currently, it's addition and subtraction. So when we turn addition and subtraction to multiplication, we call that factoring. There's no common factor. Sorry, is it in standard form? 1 is standard form, sorry. Standard form, yes. Is there a common factor? No. Is it a special case? Is it a binomial square or a difference of square? Yeah, it's a binomial square. I know by looking at this, binomial square is third term is positive. First and third are perfect squares. It's 3 terms. Third term is positive. First, and then is my middle equal to 2 times the square of the first times the square of the last? Square root of this is 4g. Square root of this is 5. 4g times 5 is 10. 20g. Double it is 40g. Then we know it's this sign comes down. Squared equals 0. So I can take the square root, and we get 4g plus 5 equals 0 minus 5 minus 5. 4g equals negative 5. divide by 4, divide by 4. I didn't use the zero property. I actually solved for the square root. Sorry. I could show that later. So my solution is negative 5/4. It's getting long. C, negative 5/4. Look, part of this is, we'll get to this later this year, but it's a long ways away. So you can start learning this technique by looking at my videos, find those, and work on it. But at this point, this video is super long, so I'm not going to make it any longer by going into too much detail. I'm going to expect you to know how to do this. And if you don't, then you're going to have to do some research in the meantime. Sorry, but I need to get this video done. This is problem 46, where we have 4 terms. Whenever we see 4 terms, we think of factor by grouping. We're going to group the first 2. We can factor out an x squared. That leaves me with x plus 4. We can factor out a negative 25. That leaves me with x plus 4 equals 0. These are correct, so we're going to pull that out. That leaves me with x squared minus 25 equals 0. This is the difference of squares. 2 terms, subtraction, both are perfect squares. That's how I knew. So that leaves me with x plus 4. And then this produces conjugates. Remember, difference of squares produce conjugates. They have to be opposite of each other. Now we have 3 boxes that multiply to make 0, so one of these must be equal to 0. Well, what value for x would make this box 0? So that's how we write that. What value for x would make this box 0? What value for x? So we set each of these binomials equal to 0. We subtract. So if x is negative 4, it would make this the 0. If x is equal to 5, it would make this box 0. If x is equal to negative 5, it would make this box 0. So all of those are solutions. And I always write them in numerical order. They don't do that. They just assume that you can place that. That's not numerical order, but that answer is D. Keep going here. Keep going. This is the heavy stuff. This is the ultimate stuff. So sketch the graph. When this graph is in this form, and when a is less than 0, so when a is greater than 0, it looks like this. When a is less than 0, it looks like this. Do you know what it looks like when a is equal to 0? It looks like a line because it gets rid of the square. Not a lot of teachers teach you that, I'm sure. They just do the positive and negative a when it's positive greater than 0. So we know since a is negative 3, so y equals negative 3x squared, my a is negative, so I know it's going to be upside down. So I don't even need to do any work because these all have positive a's. The other way you could have done it is, again, you could have created a chart, x, y, negative 3x squared, and then plugged in a couple values, 0, 1, negative 1, and you would have gotten the shape of the graph. Not needed. If you can find a shortcut, use the shortcut. Now, we're going to graph the parabola. So when I graph parabolas, we use the axis of symmetry. The formula is y equals negative x squared plus 3x minus 1. So my a value is negative 1, my b value is 3, my c value is negative 1. This is also equal to my y-intercept. That's important. So when I graph this on a chart. Let's make this a little bit smaller and move it down a little bit. So I automatically know one of the points. Can I move this over? Yeah, let's move that over just a little bit. So I already know one of my points. One of my points is going to be negative 1. So I know that. Can I decipher? Okay, negative 1. Well, that's not negative 1. That is negative 1. So I've already eliminated two graphs. I know it has to be B or D. I know it's going to be upside down because my A value is negative, so that doesn't help me. And then typically what you do is you find the axis of symmetry. The axis of symmetry. And axis of symmetry says the opposite of B over 2A. So the opposite of my B value, which is 3, divided by 2 times my A value, so negative 3 over negative 2, and 3 over 2. So my x, where is x equal to 3 halves? It is right here. That is going to be my axis of symmetry. It produces a symmetrical shape. All parabolas are symmetrical. And we know that is going to be the maximum in this point. So I already know, without doing any more work, that my answer is going to be B. But what do we do with the axis of symmetry? This is the x value. It says that my min or max, my vertex, is going to lie here. So I'm going to find my vertex by plugging in x equals 3 halves. So I take that equation, negative x squared y equals negative x squared plus 3x minus 1, and we plug in 3 halves squared plus 3 times 3 halves minus 1, y equals negative 9 fourths plus 9 halves minus 1, y equals negative 9 fourths plus 18 fourths minus 4 fourths, and y equals, that's 9 fourths minus 4 fourths, gives me 5 fourths. So my point is going to be 3 halves, comma, 5 fourths. That's going to be my vertex. So where is that vertex? That vertex is 1.5 and then 5 fourths. So it's going to be like right there. Here's the other cool thing is, since it's symmetrical, I see that my y-intercept is 1.5 away from the axis of symmetry. So its mirror point is going to be 1.5. So once I plug a couple points, I have the good shape of it. I know it's going to be that, and it's going to be B because it's over on the right side. So that's a nice, efficient way of graphing parabolas. A rocket is launched. This is one of the main reasons why I got into math. I love these types of problems. A rocket is launched atop a 75-foot cliff with an initial velocity of 170 feet per second. The height of the rocket, t seconds after launch, is given by the equation height equals negative 16 times time squared plus 107 times time plus 75. Graph the equation to find out how long. We don't have to graph it. It's silly. Estimate your answer to the nearest second. We want to find out, when does it hit the ground? Well, if it starts at time 0, this is time, this is height. So it starts at 75 feet, and it's going to do this. And so this is height. Height is 75 at 0, because if I plug in 0, my value is 75. And of course, it's 75 feet off the ground. And when is the height going to be 0? When is the next time height is going to be 0? We have to be careful, because if you back it up in time, negative time would show also. So there's going to be two values when height is 0, negative time and positive time. So there's a number of ways that we can go about finding this. You would say, hey, when is height equal to 0? Negative 16t plus 107t plus 75. And we can use the quadratic formula. The quadratic formula says that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, plugging in the values when a equals, we're gonna factor out a negative, and so a is going to equal 16. Let me see what I did. Let me see what I used for a, b. Yeah. So a equals 16. I'm going to change this equation. So, sorry, I'm going to change this equation. I'm going to factor out, I want my a to be positive. I factor out a negative 16t squared minus 107t minus 75. Divide by -1, we get 0 equals 16t squared minus 107t minus 75. So my a is 16, my b is -107, my c is -75. So if I plug in all those values into this, I end up with positive 7.328 and negative 0. What was it? 0.63 something something. So this is the negative 0.6 seconds, and this is the positive 7.3 seconds. So it's going to be A. Trust me on this equation. I don't want to do all this math. I really do just want to. This is the opposite of -107 plus or minus the square root of -107 squared minus 4 times A times C all over 2 times A. So if you simplify this, if you square it, if you multiply this, combine those, take the square root, do the plus and minus value of it, I promise you get those two values. You can work it out if you know how to use the quadratic formula. I just want to get done with this at this point. It's 1,000,000 degrees in my room, and it's 6:22, and I gotta have dinner. All right, solving this we hopefully see is the difference of squares. So solve the equation. So we would do 5x minus 3, 5x plus 3 equals 0. We would set each one equal to 0. 5x minus 3 equals 0. 5x plus 3 equals 0. Let's add 3, 5x equals 3, divide by 5. X equals 3/5. Minus 3, 5x equals -3, divide by 5. X equals -3/5. So my solution is actually plus or minus 3/5. And that would be B. That's one way. Lots of ways to solve this. You could isolate for the variable if you wanted to. Solve the equation by completing the square. Again, a somewhat complex method. We want to move the constant over because we're going to create a binomial square here. And so the way we create a binomial square is we take half of the b value and square it to make 9, and we're going to add 9. So this value would make it a binomial square. But what we do to one side, we have to do the other. We have to balance it. I'm just going to move this. That's sort of the side work. That's how we get that value on what we want. And we know that this is a binomial square. We take that half value and we could write that. And that makes 25. Now we're going to solve by taking the square root. How do we get root? We can't get to the variable because it's being squared. So we take the square root. We get x plus 3. These cancel. Equals, whenever we take the square root of a value being squared, we have to do plus or minus 5 minus 3. We're going to isolate the variable. We get -3 plus or minus 5. So we have -3 plus 5 and -3 minus 5. That becomes 2. This is -8. So my solutions are -8 and 2. -8 and 2 is B. All right, we're in the home stretch. We're almost there. 52. Solve the equation by completing the square. Right, so we need to complete the square. 2x squared plus 4x minus 5 equals 0. Whenever we complete the square, my a has to be 1. So how do I get rid of this? I'm going to divide everything by 2. And that gives me x squared plus 2x minus 5 halves equals 0. Now we're going to move the constant over. That gives me x squared plus 2x equals 5 halves. Now we're going to take half of my b value, which is 1, and square it, which is 1. So we will add 1 to both sides. And this equals a binomial square, so it's going to be x plus 1, it's my half value squared, equals, well, 1 is equal to 2 over 2, so this is 7 halves. And now we're going to take the square root of both sides. That becomes x plus 1 equals plus or minus the square root of 7 over 2. We're going to subtract 1, x equals -1 plus or minus square root of 7 over 2. We have to rationalize. Woo! We can't have a square root in the denominator because this is equal to rad 7 over rad 2. To rationalize, we multiply it by rad 2 over rad 2. Another technique, something you need to check and put some time into. That gives us rad 14 over 2. So this equation now becomes x equals -1 plus or minus rad 14 over 2. Let's get like denominators. -1 is -2 over 2. So rad 14 over 2. Now we have like denominators and we can combine them. -2 plus or minus rad 14 over 2. And that would be my answer. Woo! -2 plus or minus rad 14 over 2. That would be, to no one's surprise, A. 2 more problems. All right. Solve the quadratic equation. So my A value is 1. My B value is 8. My C value is 14. Whenever we use the quadratic formula, it has to be equal to 0. Quadratic formula, anything can equal A. And we're going to do the opposite of B, plus or minus square root of b squared minus 4ac all over 2a. Let's substitute it. So opposite of 8 plus or minus 8 squared minus 4 times 1 times 14 all over 2 times 1. That's -8 plus or minus 64. That's going to be plus minus 56 all over 2, which is -8 plus or minus rad 8 over 2. You can simplify rad 8 to plus or minus 2 rad 2. Go find a video of mine that shows how to simplify radicals. We look for perfect squares. This is not a perfect square, but we can simplify it if it has perfect square factors. 4 times 2, rad square root of 4 is 2. That's why it became. And now we have to simplify this because each one has a common factor of 2. So we can simplify each of those by 2. And that gives me -4 plus or minus rad 2 is my answer. -4 plus rad 2, -4 minus 2. So that is D, actually. We go back to D. Not all answers are going to be. And last but not least, describe the most efficient method to solve the quadratic equation. Well, we're not going to use difference of squares because we would have to get rid of that 2. We are not going to, we're not going to solve, right? So we can't, can we factor? Yeah, we could factor. Quadratic formula is nice. Solve for x. No, we can't solve for x because there's 2 x's. So we know that it's not going to be this. The square root method, we can't take the square root. That's sort of the same thing. Square root method, hello, both of those the same. Factoring and zero product principle. We could do that, but factors of -6, factors of 6 that subtract to make, no. So if we do a times c, This is my A, this is my C. That gives me -6. Factors of 6 are 1 and 6, 2 and 3. When subtracted equals 6, signs are different. Bigger is negative. So none of these, that equals -5. This is -1. None of those equal my middle. So I can't use the factoring. So my answer is A, quadratic formula. And we are not done. 55, what? Determine the number of solutions. I head faked myself out. Silly. All right, determine the number of solutions. So we have this thing called the discriminant. Maybe DE, discriminant. The discriminant is part of the quadratic formula. It's b squared minus 4ac in that. So we know something about this piece inside here. It's not, the discriminant is not the square root. My arm is spazzing out. Did you see that? The discriminant is really, this is the discriminant, but we know that it's inside this in the quadratic formula, and square roots have to be positive. So there's some logical stuff. When b squared minus 4ac is greater than 0, we know that we're going to get a solution. We're going to get two solutions. When b squared minus 4ac is equal to 0, well, that square root ends up being one value, so this is one solution. And when b squared minus 4ac is less than 0, it's a negative number. We can't take the square root of a negative number, so it is no solution. So we can utilize the discriminant, and this is A. So we'll start plugging it in. A equals, oh, well, I factored out. I made it. Factor out a negative again. So I factored out a negative, which gave me x squared minus 6x minus 6 equals 0. I divided by -1, which gives me x squared minus 6x minus 6 equals 0, where A equals 1, B equals -6, C equals -6. So B, -6 squared minus 4 times A times C gives me 36 plus 24, which gives me 60. So that is greater than 0, so I know that I'm going to have two solutions. And we are done. Woo, baby! That was a long one. Good luck. Hopefully you did well on this. If you can do all these and get a really good score, then you're going to go to geometry next year, probably honors geometry.